All right, in this video, I'm going to be going over your first 3 quick checks from Chapter 7. So if we look at quick check 7.1a, some of you did fabulous, some of you made a few minor mistakes, so if you got all the problems correct on this quick check, you can skip this part until we get to the next quick check. But this is one where you needed your calculator. So from Chapter 7.1, solving a system like this, 3x plus 2y equals 6, y equals 2 ln of x minus 1. The most common mistake I saw here was students put parentheses around this x minus 1, but there are no parentheses there, so don't make that mistake. If there's parentheses, then they go in parentheses. If there's not, it's just ln of x minus 1. And the typical way that I expected you to solve this was by graphing. If you graphed the first equation, so again, subtracting 3x from both sides, dividing by 2, right? You could have written it as negative 3 halves x plus 3, or just typed in exactly what you have there. They're going to intersect at this point. You used your intersect feature to find 1.85 and 0.228. If you gave me at least that, full credit on this problem. If you used the solve feature, you might have found what x is to more accurate decimals, but then you'd need to substitute that back in to one of your 2 equations to find y. So be sure you do that as well if you want more decimal places of accuracy. For number 2, right, Dr. C owns Math Pun Mugs Incorporated. If P is the price of 1 unit, and the amount of units they can supply is given by S of P, so notice here, right, instead of it being S of X, where X is the number of units, this is S of P, right, so this is dependent upon the price. So slightly different than what we saw in our class notes or in the homework. But same idea, the equilibrium price is when the supply and the demand are equal. So to solve this, again, either punch in this equation in your calculator, it's going to give you a beautiful cubic, this upside down parabola, right? Graph the 2 of them where they intersect. They're going to intersect when P, because in this case, P is my independent variable, right, is $10. Or again, if you solve by setting this equation equal to another equation, it's a cubic equation. If some of you tried to do it by hand, and that was not my intent for you, right? It's not a linear equation that's easy to solve. So use your calculator, take advantage of it. If you want it to be most accurate, it'd be $10 and a penny. So be sure if we're talking about a price, put a $sign there, right? It's money. So that was that quick check. And this was my cow pie mug. All right, looking then at quick check 7.1b. Go ahead and pause the video if you need to, so you can then pull up 7.1b yourself and kind of look and compare. But the correct solutions were negative 3.7 and negative 1/3 3. Again, if you got this right, skip to the next section where we talk about the last quick check. But if you didn't, let me talk through my solving procedures, because this was one without a calculator. What I did here is, this is linear, and this is a hyperbola, because it's an x squared minus a y squared. And so without a calculator, I can't graph it and see where they intersect. So I do notice that 3x and 9x squared, hey, 3x squared is 9x squared. So that's my hack. I'm going to go ahead and solve for 3x, right, by subtracting 2y from both sides. And then if I square both sides, I get 9x squared. And I'm going to just sub in entirely for 9x squared. So 5 minus 2y squared is 25, minus 10y is minus 20y, plus 4y squared. So if I put all of that in for 9x squared, and then have minus 2y squared equals negative 17. All right, I'm going to add 17 to both sides. I'm going to combine my like terms here, and I'm going to have 2y squared minus 20y plus 42 equals 0. I've got a common factor of 2 that I can divide out from all of these. So I've got y squared minus 10y plus 21 equals 0. I'm going to pause there. Some of you started the exact same way, but then you divided everything by 3, and then you substituted x equals 5 minus 2y all over 3 in for this x. And then you squared it, and then you multiplied everything by 9, and you ended up getting the exact same thing. And that's perfectly fine too, if you want to do it that way. I like my shortcut hack. Y squared minus 10y plus 21 is 0. So factoring this, you get y minus 7 or y minus 3, so y is 7 or 3. If y is 7, I'm then going to substitute that back into equation 1 here because it's much easier to solve for x. So 3x plus 14 equals 5 means 3x is going to equal negative 9 if I subtract 14 from both sides. Divide both sides by 3 and x equals negative 3, so that combo is negative 3, positive 7. Likewise, if y is 3, plugging 3 in here, I'm going to have 3x plus 6 equals 5. Subtract 6, you get negative 1. Divide by 3, you get negative 1/3. And so my solutions, again, were negative 3, 7, negative 1/3, 3. If you decided to solve for y and substitute that in, so you had an equation entirely in terms of x, here is what your work would have, should have looked like for that. So again, solving for y and then subbing in for y squared. Either you're going to sub in for y and then square it, or I just went ahead and squared everything and then put it in. Simplifying, you're going to want to multiply everything by 2 to clear that fraction to make it easier. And at the end of the day, you're going to get a quadratic that will factor a little less prettily because x could be negative 1/3 or negative 3. And then find the corresponding y's that go with it. So, yep, those are your solutions. And then last but not least, we're going to look at quick check 7.2a. All right, so again, this is the key. Evaluate each sum or product or state not possible. So 7.2 starts matrix algebra. And so here, if I'm multiplying a times b, again, a is a 2 by 3 and b is a 3 by 2. Their inner dimensions work. So matrix will be defined, and I should end with a 2 by 2 matrix. And so if I go row times column, so 1 times 4 is 4, negative 1 times 7 is negative 7, 2 times 2 is 4. Add those all up, and I get positive 1. If I go row times my second column, first row times second column is going to give me my first row, second column total entry. So 1 times 3 is 3, negative 1 times 9 is negative 9, 2 times 1 is 2, 3 minus 9 plus 2 is negative 4. Negative 2, 0, 3, second row times first column is going to be my second row, first column entry in my product matrix. Negative 2 times 4 is negative 8, 0 times anything is 0, 3 times 2 is 6, and that adds up to negative 2. And then last but not least, negative 2 times 3 is negative 6, 0 times 9 is 0, 3 times 1 is 3, that adds up to negative 3. Now, what if I switch the order? Now, some of you did all of this in your head, and that makes me slightly suspicious, but maybe some of you can do things that I cannot, right? B times A, I ran ahead and rewrote it. Again, B is a 3 by 2 and A is a 2 by 3, so my inner dimensions work. I'll be able to multiply, but my end matrix should be a 3 by 3. So again, row times column. So 4 times 1 plus 3 times negative 2 is negative 6, right? So 4 minus 6 is negative 2. I'll let you look at these, and if you made mistakes on this problem, they were minor for the most part. So pause and double check if you want, but I'm not going to take you row by column for every single one of these. A plus B, so when we look at the sum, A is a 2 by 3, B is a 3 by 2, you can't add those because in order to add two matrices, they have to be the exact same order, n by m, n by m, or m by n, m by n, right? They have to be the same. So this is not the same as this, it's not possible. However, if you remembered what this notation T meant, A transpose, again, A transpose means we take all the columns of A, right, and make them rows, right? So this column, 1, negative 2, is going to become the first row, 1, negative 2. 1, negative 2. The second column becomes the second row. The third column becomes the third row. So A transpose. So now A transpose plus B transpose, this is a 3 by 2. This is a 3 by 2. They are the same. So this addition is defined. And we define it by just going element by element. So 1 plus 4 is 5. Negative 2 plus 3 is 1. So on and so forth. Thank you for watching.